Hi, I'm Chuck Mason with Mason's Pro Septic, and we are here today in Schuylkill County to perform a PSMA Septic inspection. So first we're going to start in the house. We're going to check the plumbing, make sure everything's connected to the septic system going out to the tank. We're at the kitchen sink. We'll check down below. I can already tell there's no garbage disposal here. We're going to go downstairs. This is the utility room. So right above us is that bathroom. You can actually see the toilet line there going down, and then inside the wall she's dropping. I can't see through the wall, so I'm not sure if that's connected. And then you'll also notice there's a basin tub. Now this basin tub is coming into this sump pump pit, and this is a natural grade sump pump pit. It's a footer drain. So whatever comes through that sink goes in here and goes to wherever that pumps out. We don't want the washer coming in here. The washer's got to go out to the tank. This house has been winterized, so I don't know how long it's been unoccupied, but it's been unoccupied long enough that they needed to clear out all the lines. And we're going to be running water later, but we're going to have to run it from the pressure tank with the house shut off. We're not going to be able to test flow from the house by flushing a toilet or running a tub to see if it enters the tank. However, because of the pipes outside, I'll be able to run my camera through and verify whether or not there's an issue with the line. So 95% of all the pipes are hidden. So you can't tell if everything's connected unless you actually run each facility into the tank. So now we're at a point where we're going to go back outside. We're going to check the line going out, run the cameras, see what we can see. Okay, that's a sign of a blockage. That looks like grease, food grease. There must be something further down the line that created a blockage that held the water. And then when we were adding water from the house, washing dishes, the grease floats to the top and clings to the top of the pipe. There's a little bit more debris, even more debris. Oh yeah, well, there you go. That's a broken pipe. You can see the roundness of the pipe. And this is the roundness of the pipe before it. This has debris on top. So this is going to be the bottom. That should be the top. You can see the separation, and what can happen is paper can get stuck on the sides there, eventually clogs everything up. So right there is something that needs to be repaired. That's an unsatisfactory condition. You can see how the camera goes down into the bottom of the next pipe and will kind of come up into the tank. I'm going to turn on the sonde on the camera head. There it is. That's about 2 foot in front of the tank. So that would have to be dug up and replaced. Whoever's fixing this can avoid digging into that asphalt and just take it from the tank. Cut out that bad section, put a new piece right in, and then I would recommend a clean out here. Just knowing that the camera went through the line, we pinpointed where the break was, and we knew we were about 2 feet away from the tank, and of course we come over. Obviously, this lid is cracked. Probably whatever drove over the pipe there, drove over the lid here. This tank is either leaking or it's cracked. And that water should be all the way up to about 8 to 10 inches underneath the underside of the tank top, 3 inches below the inflow coming in. And when we ran the camera into the baffle, I didn't see water. Now, I can already see that this is what we call a 2-seam tank, or excuse me, a 2-part tank with a seam. I can actually see the seam, and it's usually right below the outlet baffle, which we're going to look at in a second. So it's not leaking at that seam, it's leaking from the floor. It's possible this tank was pumped, but if it was, they didn't get all the poop out of it. Normally what we would do is we would run water from the house, watch it come through the pipe, come into the tank, and then ensure that it's leaving the tank without any issues. We've cameraed the line, the line's open, we do have a break, water would have came through into this tank with no problem. Problem is now we can't get water from the tank out to the field, and since we're doing a hydraulic flow test because this property's been unoccupied, the only way to get the water into the field is to dig up the outlet inspection pit. It's a little lid over the pipe that's leaving, which allows you to look right into the outlet valve. So you'll see the pipe, that's your outlet pipe. The water level should be equal to the bottom of that outlet pipe. And you can actually, if you look at the inside of the baffle, you'll actually see a water ring where the water was always holding. You'll see the concrete that was underwater was always smooth, and the concrete that's above the water, a little flaky. But we can also see how far down the water is compared to the bottom of the baffle. And that seam that I was talking about would be equal to the bottom of that baffle. So we have an unsatisfactory inlet line. It's broken right there. We have an unsatisfactory septic tank. It's either leaking or it wasn't pumped right. Now we're going to investigate the outlet. And there's a broken pipe. Like something pushed in on the side there. It looks like it could have been driven over. It's very possible that somebody drove through this area. So that pipe is broken right before the start of the absorption area. And this absorption area is a drain bed. Well, at least I assume it's a drain bed because I have a T here. And as soon as I got over that break, you'll see these holes. They're the perforations. So as the water's coming through and fills the line, once it fills up, it drains out these holes into the stone aggregate down below. So we're gonna push this through the drain line. So we are literally in the absorption area. Oh yeah, it's a drain bed. I'm in the back end of the drain bed right now. That camera's sitting right there. This is where I found the edge of the gravel when I was probing for the bed. All right, I'm gonna move back to the camera. I'm gonna try to push it as far as I can. Right. The thing is also when we're looking at this, you'll notice there's no water holding in the pipes. That 4-inch pipe has 1 inch of stone on top, should have 7 inches of stone below. And the PSMA standards and guidelines indicate we can have 7 inches of water up to the bottom of that perforated pipe. But if it's up into the pipe, we have to do a hydraulic load test to make sure it works. If it's above the top of the pipe, top of the stone, that's an unsatisfactory and it needs to be replaced. So we're down here someplace because there's no water holding in the pipes. So now we'll investigate the bed after I pull that camera out, probe down into this ground and show you what we're looking for in the bed. Okay, so I've already moved the stone out of the way. So when I bring the bar back up, what we're looking for is any water line on the bar. Now, we still have moisture, but there's no dripping. I have another one about 15 feet away. Again, we have moisture, but it's not, there's no water running off of that. I see tire marks everywhere, so somebody could have just been driving on here in like a development area. I can probe down, no interference from large rocks, and I can literally pinpoint the edges of the drain bed and get the exact measurement. On properties like this with this shale everywhere, it's a little harder to get to the perfect edges. So this is somewhere between a 32 to 36 long by 16 to 18 foot wide, possibly even 20 drain bed. We're going to start up the second day of the hydraulic load test, get our 400 gallons in, take a measurement of the water, and watch it go away again tomorrow, and then we'll be able to write up the report. I've got my garden hose connected to the pressure tank. This is an actual water meter. So what we're going to do is put this right into the outlet because we can't add it to the tank. So we're going to dip the bar here. And you want to get to the bottom of the stone aggregate, but don't want to puncture into the soil. Pull the bar back and see where our water line is. And you see it dripping off. And it's about 10 inches. So there's your water. So it did exactly the same thing. It accepted the 400 gallons of flow. And there's actually, now, probably can't see it in the camera, but I can see that there's more than 5 inches of dry stone aggregate above that water level. So it never got up into the pipe. So the expectation is for satisfactory tomorrow when I get here, it'll be exact same condition as when we found it this morning. We still have to go into the basement and we got to run water into the washing machine line to make sure it's coming into the septic tank and not going into that sump pump pit. The sump pump can go into the creek, but the washing machine has to come here. Guess what? It's coming in here. The sump pump line doesn't have a check valve. If that line is connected to that line when the pump turns on, that pump is then pushing water into the washing machine. So we'll just keep this running. Okay, we're gonna shoot out of it. Now we gotta go look for the dye. First place you look is the stream. You've got a sump pump. Why wouldn't it be going to the stream? So I don't see anything here, but sometimes it'll take a while. So what we're going to do is go back up alongside the house, make sure it's not connected to any rain spouts, and definitely it cannot be connected to the septic system at this point because of the sump pump that takes on groundwater. The sump pump's taking on groundwater and it's going into the septic tank. That's unnecessary flows. That's a situation where rain can impact the septic system because there's a direct shot of unnecessary flows into the tank. Yep. The washing machine is connected to the septic tank. Problem is, so is the sump pump. The groundwater infiltration that comes in around the foundation fills up that pit in the corner, turns the pump on, and pumps the rainwater from the basement of this house into the septic tank, which could overload that absorption area. We get heavy rains, and this is going back to what we were talking about before when people ask, can rain affect the septic system? Well, this is a direct flow of rainwater into the septic system, and this will absolutely wipe out the septic system. So we have another unsatisfactory situation. So that plumbing situation down there has to be corrected. That sump pump needs to be disconnected and sent someplace else. And I'm not sure what's involved because everything's behind the wall, but we cannot have rainwater, groundwater coming in here. So the washing machine's supposed to go in because this is considered wastewater. The sump pump, though, takes groundwater from the foundation of the home. So every time it rains, water runs down the hill, it hits the foundational wall, runs down the wall, and then collects in the stone in the soil below the house. That's the point of least resistance so that the whole floor doesn't flood. So the water level begins to raise inside the sump pump, but when the pump kicks on, it's taking all that rainwater from the footprint of this house and putting it into the septic system. Those are flows that system was not designed for. Those are flows that pump could run for 5 days straight this April. And it's very possible the water that we are seeing in that tank when we first got here came from the sump pump. Then maybe, yes, the tank was pumped and it was pumped dry. Poorly, I may add, I will always say that. But it had water in it, it was crystal clear. So that water could have come from the sump pump. So you're adding water that the absorption area needs to settle down or accept and absorb on top of the wastewater flows from the house. So if 4 people move, 6 people moving, using facilities all the time, and then it rains, you could be overloading the system, creating backups and breakout of the effluent water in the trench. If this house was built in 1900, this original portion of the house may not have even had plumbing in it. Could have been a outhouse. At some point, they put plumbing in, but it appears that all the plumbing is in the additions. Everything behind this wall. I think the system may have been installed while this was connected this way. But again, it's not up to us to figure out how it happened or why. Our goal is just to prove that it is or isn't going in. And we've determined that after this little test here, groundwater is going into the septic system, which could destroy it. So just because it passes the hydraulic flow test doesn't mean that we want to keep putting unnecessary water in it. It will work better without those flows going in. So it's working the way it was designed to operate. All those other unsatisfactory conditions need to be correct. I mean, the good news is that the absorption area, which is the most important part, and that's what dictates the $30,000 to $50,000, that's the most important part. Everything above it, in front of it, towards the house can be correct. That sump pump absolutely has to be disconnected, and that pipe should be capped. There's no check valve on it. It's not the hokiest thing I've ever seen.